Santoshi, are you in Misra itself today?
Yes, sir. I'm in Mr. Ranchi.
Okay. So, what about the climate there?
It is hot there.
See, in Kerala now it is rainy season.
Oh, okay. It's good then.
I think within 1 minute we can start.
Yes, sir.
ನೋಡಕ್ಕೆ ಅಂದ್ರೆ ಅದು ಹೋಗಿ ಆಕಿ ಅವ್ರ ಅಮ್ಮಗ ಹುಡುಗಿ ಬಂದು ಯಾವ ಹುಡುಗಿ ಕಳ್ಸೋದಂತ ನಮ್ಗೆ ಗೊತ್ತಾಗಲ್ಲ ಹೆಸರುಗಳು
See, dear participants, we request all of you to mute yourself. Otherwise, only when you want to speak something, please unmute and speak. Otherwise, please keep your mic muted throughout the session. Santoshi, shall we start?
Yes, sir. We can start.
Okay, then I will introduce you. Okay. Good morning, dear friends. Hearty welcome to the online problem solving session series organized by Maths Aspirants. As you know, Maths Aspirants is a collective of mathematics lovers, students, research scholars, postdoc fellows, faculty members across India, started by myself in 2017. And we used to organize several online programs to help the students who are preparing for different national level competitive examinations for mathematics. As a part of that online problem solving session series, today we have a special session focusing on the forthcoming CSIR-NET examination. Today, our session is on selected problems from probability and statistics, and we blessed to have Mr. Santosh Kumar Chaudhary, an assistant professor of statistics, Birla Institute of Technology, Misra, Ranchi, Jharkhand. Mr. Santosh is currently pursuing PhD in mathematical statistics at Department of Mathematics, IIT Kharagpur, and he did MSc in mathematics from IIT Delhi and also MSc in statistics from IIT Bombay, and he qualified IIT JAM examination with All India rank 17 and GATE examination with third rank and CSIR JRF with All India rank 50. So I'm sure that we have got a very right person to discuss problems from the area of statistics with you today. So I'm sure that today's session will be certainly helpful in your final round preparations for the forthcoming CSIR-NET examination. And also, I appreciate Santosh for doing many YouTube lectures to help the students who are preparing for this type of examinations. And he is doing several problem solving sessions in his YouTube channel. And all these are freely available in YouTube. So anyone who wish to pursue higher mathematics and to appear for this type of entrance examinations, so watching that sessions will be really helpful. And I would like to express my sincere gratitude and thanks for accepting our invitation to join with us and handle a problem solving session for in our platform for our members. So I welcome everyone to this program. Welcome, Santosh.
Yeah, thank you so much, sir. So let's start. So I will share screen through my different device. So this will be lecture. This is the notes actually we have prepared for students. So this contains questions from CSIR-NET statistics portion. So initially it was unit 4, now it is mixed actually. So nowadays exam is happening. Like if you see the syllabus, so statistics portion is covered in unit 4 in syllabus. So we have selected problems from that, and I will be solving not all because there are broad topic in statistics. So I will be focusing mainly on basic probability, basic random variable, or just statistical inference, basic things. So like the first question from Bayesian inference, so I will skip this. Second is from descriptive, that we can try, but I think it will take time, so let me just focus on the third problem. Okay, so let's start on this is from basic probability. So third question, if you read, so it is from basic probability, and the topic of this question is Bayes theorem or total probability, that is also covered in class 11 12. So if we see the class 12th book intermediate level, so this question is also in the book at intermediate level. So we can see this. So first let us read, and you can also read this question. So question is saying, in an examination involving, and these questions are from CSIR-NET December 2023 paper. So this question actually, the first 10-15 questions. So in an examination involving multiple choice questions, a student works out the solution in 50% of the questions. In the remaining questions, the student guesses the answer. However, when the answer is guessed, the probability that it is correct is 0.30, and when the student work out the solution, it may be wrong with probability 0.10. So if the answer to a particular question is correct, now it is given that the answer to a particular question is correct. So what is the probability that the student guessed the answer? Okay, so first of all, you all read the question and try to understand what informations are given and what we need to find. So the question is saying there is a multiple choice question, and a student either student work out the solution 50% of the question, and the rest 50% he or she guess. So work out or guess. Okay, and next it is saying, however, the when the answer is guessed, the probability that it is correct is 0.30. When the student work out the solution, it may be wrong with probability 0.10. Okay, so the question is, now it is given that the answer to particular question is correct. So what is the probability that a student guess the answer? So I read it twice just to make you understand. Now you can read once more for yourself, and then we can start solving. So I can write here also. So the background of this, so you might be knowing Bayes theorems. So that is the, so this question is based on Bayes theorems. And again, I'm saying this topic is already covered in school level mathematics, probability theory chapter. So if you see class 12th probability, this topic is already covered there. So let me write the statement, then I will solve it. So if we write the Bayes theorem, so suppose this represents sample space, and there may be as many partitions as, for example, it is event E1, it is event E2, and so on. Let's say event En. So what I'm saying, E1, E2, En, actually these are partitions. So it is like Ei intersection Ej is phi for all I different than j, and if you union all events, it will give you sample space. So this is sample space is omega, and so let A be some subset of omega. So means A is also an event. A is an event, and that is given. So now if they ask you the probability of some event Ek given A, so Bayes theorem says this formula. Even if you would like to find probability of A, that formula comes. This is the theorem of total probability. Probability of Ei into A given Ei and I from 1 to n. So this formula is called theorem of total probability. So this is called theorem of total probability. So we are finding total probability of A with respect to events Ei, and here is Ek is one of the event out of one E1, E2, E3 up to En, and we have to find the probability Ek given A. So if you use the similar conditions, so like probability of Ek intersection A upon probability of A, and if we further use multiplication rule of probability, so the numerator will boil down to E of k into probability of A given Ek, and upon then probability of A, we can use the total probability like the I have written there. So probability of Ek, yeah, Ei, and probability of A given Ei, I from 1 to n. So this formula is called theorem of total probability. I will be using this formula here. Okay, so if anyone has any doubt, you can unmute and you can ask also. So if you want to ask something. So I hope everyone, at least those from probability background, if you are not, might be knowing what is a Bayes theorem. Okay. So now let us use this in this question. So what are given here? So we have to first make the partition. So what will be E1, E2? You first decide E1, E2. So the what the probability they ask? What is the probability that the student guesses the answer? The one of the partition will be a student guessed answer. So you may write like student guessed answer. One partition I will take. Now what are the other options here? So you have to write the other options. So other options will be, so what they said, a student work out the solution 50% of the questions. So the other option is a student worked out. Okay, answer or the question you can say. So they worked out or they guessed. There are two choices we have. So student worked out solution 50% of the question, and the 50% of the question the student guessed actually. Okay. So now if the student guessed, the probability that is correct 0.3. If the worked out, the probability of wrong being wrong is 0.10. So being correct is 0.90, right? So if a student work out, the probability is a very easy question actually. So this is also found in class 11 12 book. Now you have given that the answer to the particular question is correct. So it is given. So I will name it event A. So event A is answer is correct. So answer to the particular question is correct. So that way I just defined E1, E2 and A. Now what they are asking? So they are asking what is the probability that the student guessed answer. So means E2 given A. Okay. So we can solve this question within 10-15 seconds, but since I'm making you understand, that's why I'm writing all these things. Otherwise directly you can write the formula and just 10-15 seconds you can find the answer. So use that formula actually. So what I've written here in the Bayes theorem, if you use that formula, probability of E2 into A given E2 upon probability of A, so it will be probability of E1 into A given E1 plus probability of E2 into A given E2. Now see, all the informations we need are given in the question already. So you have to just interpret that information given in the question. So see, if I ask you what is the probability of E1? So what is the probability of E1? Yeah.
1/2.
Yeah. So chat I'm reading. Where can we find the video lecture of statistics? You can see in on YouTube channel there are many people like Harish Garg sir also uploads video. I also upload. So there is my channel name as MathStats. You can search on YouTube or Google. So there is my YouTube channel. I also upload videos there. Harish Garg sir upload there, and there are many people. I think they upload for CSIR-NET solutions. So you can watch there. Okay. So probability of even a student work out the answer. So here it is given that 50% of the questions, it is 1 by 2, right? Probability of E2, so remaining they guess, so it is also 1 by 2. Okay. Yeah, it is math stats. You can just search. So this is a channel, my YouTube channel name. So okay, see. So probability of E1 is 1 by 2, E2 is also 1 by 2. Now what we need more? We need probability of A given E1. So given E1 means under the E1 situation, what is probability of A? So under the E1 situation means if a student worked out the answer. So if they worked out answer, then what is the chance that it will be correct? See, it is given in the questions. We can tell. Okay, nice. So okay, so you can just see. You just have to take out the information from the question. So if a student worked out the answer, the question is saying if they worked out the answer, uh, the probability of being correct is 0.30, is it? So 0.30, right? And probability of A given E2, A given E2. So if a student guessed the answer, what is the probability of being correct? So read there. If the student guess, oh 1 minute, I think I have written wrong here, right? Yeah, it is wrong, 0.30. So first was for A given E1 is a student worked out the answer. If a student worked out the answer, the wrong being 0.1, so correct being 0.90. So I'm correcting this. I have written wrong here. So A given E1 means if a student worked out the what is the probability of being correct. So it is saying that if a student worked out the solution, wrong होने की probability है ना, it is 0.10 being wrong. So being correct is 0.9. So it is A given E1 is 0.9 and A given E2. A given E2 means if a student guessed the answer. So what is probability of being correct? So now it is 0.3 actually. So it is given that if a student guess the answer, the probability that is correct 0.3. Now you have all the four information needed in the question. You just replace it. So I think one of you already answered it in the chat. So others can see whether are you able to do or not. So you just see what is the answer and then we can match. So my let me solve here. So we were solving E2 given A. So probability of E2 was 1 by 2. A given E2. So see, I have written information there I have copied from. So 1 by 2 and the probability of A given E2 we have written is 0.30 upon 1 by 2 into A given E1 was 0.90 half into 0.30. So we could have just started writing solution from here. So those who have already background in probability or they know, so we can directly start writing solution from here. So that's why I said you can just solve in 10-15 seconds this question directly. So the background I told you because I'm thinking few of you are already from mathematics background, they might not be knowing statistics already. So just you simplify this, the half will be get cancelled out. So 0.30 upon 0, okay, what will be there? 1.2 so 30 upon 120, it is 1 by 4, I think 0.25. Yeah, so the one Amin, you answered correctly. So 0.25 is the answer. So this was the theory and the solution is the following. So if anyone has any doubt, you may ask on chat or by unmuting. Okay, so answer is yeah.
Probability of E2 by A, oh, what does it mean, sir?
Given, it is given actually. So just like the formula was probability of E2 given A. Given A means you are already known that event A has already occurred. Then what is the chance of being E1 or E2? So they are asking the probability of being E2 given E1. So I have defined here what is the meaning of E1, what is the meaning of E2. You can read here. So first you can read question, then from that question you can just define the E1 E2. E1 E2 are the partition or the possibilities you can say. So E1 was just a student worked out the answer, E2 was a student guessed answer. That is the two possibilities, and the answer being correct or incorrect, maybe answer correct or incorrect, maybe wrong or correct. So A is event, answer is correct. So E1 is event, E2 is event, A is also an event. And the question you see, if the correct answer of a particular question is correct, if means they have given you, so that is the event A I named. So given A, then what is the probability that the student guessed the answer? The student did two things. He may guess or he may work out. So the E1 was worked out and E2 is guessed. So probability is, what is the probability? They guessed. So probability of E2 given A. And the this is a conditional probability. So already you can see the conditional probability formula. So I first derived the formula here. So you can see here I derived the formula. So how formula came? So this is the theory behind this question. So how this formula came? So probability of ek given a, where k may be anything, whether 1, 2, 3, dot 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 up to n, anything may be. So like n, I have 2 in the given question. So there are 2 partitions only. Okay, so it is E1 given A. So given A means you are already known that event has occurred, and the first one what I'm writing, so what is the chance of occurrence of event Ek? So this is the formula for the Bayes theorem, and the theory regarding this topic I'm again saying, in intermediate books you see probability chapter you will find. So it is already in school level mathematics book. Okay, probability chapter. Okay, I think we should move on to the next question. So answer is 0.25. Still, if you have any doubt, then we may discuss. Otherwise, I will go to the next question. So this was asked in December 2023 paper. So this is from December 2023 paper. You can check the paper also. Okay, let's go to the next question. So those who have idea of random variable, we can discuss fourth question also. So the fourth question, if you see, so question number 4 I'm talking about. Fourth question is xy be the random vector with the joint moment generating function this. So they have given the joint moment generating function. So what is the probability? So again, those who had mathematics probability courses in BSc or MSc, I think everyone doing MSc mathematics also had a course in probability statistics. So in that you might have studied this topic, MGF, moment generating function. So just I will briefly explain the theory, then we'll solve this question. So it is saying xy be the random vector with the joint MGF, you have given this, and they are asking to, so what they are asking here, probability x plus 2y more than 1. So what is probability that x plus 2y will be more than 1? Okay, so let's see. So first let me explain you briefly. So here the MGF, if I define, so it is joint MGF. So definition of joint MGF, if you write the definitions, it is the m of x comma y t1 comma t2. So the definition is expectation e raised to power t1 x or x plus t2y. This is the expectation if you expand. So it is given that, and now you can further open it. So let me come to the point. So there is a one result. So the theorem I will be using here is, if joint moment generating function of x and y if equal to product of the marginal, so moment generating function of x with respect to variable t1 and moment generating function of y at t2. So if joint MGF, moment generating function, is equal to product of marginals, so they say that x and y are independent. This reality if and only. So it is if and only if x and y are independent. X and y are independent. So this is the result that I will be using. And now the second result I will be using here is, so x has binomial n comma p. So if and only if, so anyone would like to tell, if random variable x has a distribution binomial n comma p, then what is the MGF, moment generating function of this distribution?
Q plus P raised to D the whole power n.
Yeah, so q plus p e raised to power t whole power n. So I will be using these two actually. I will be using these two theorems during this question, solving for solving this question. This two theorem will be used. One is when joint MGF is product of marginal MGF, and the second one is binomial MGF. And you know, in case of binomial, the support is 0, 1, 2 up to n. Support means the value of x. So if x is binomial np, then x can take value 0 to n only. So okay, so based on these two theorems, I'm solving the next question. See, so here I'm solving. So you see carefully. So here it is mxy t1 comma t2, it is written as a product of two functions. One is function of t1, other is function of t2. So it is the mx t1 into my t2. So when joint mgf is product of two mgfs, so means they are independent. The first thing is x and y are independent. And second thing is, if you compare, so we see that mx t1 is actually 3 by 4 plus 1 by 4 e raised to power t and whole power 2, and my t2 we have is 5 upon 6 plus 1 by 6 e raised to power t2 whole power 3. So now by using that theorem I told, so you can tell me, so anyone can tell me what is distribution of x and what is distribution of y you find using mgf of binomial.
Sir, X follows binomial with P1 by 4 and N2.
Yes, and this is binomial
3 and 1 by 6.
3 and 1 is correct. So now we just calculated distribution of x and y. So using mgf uniquely determine distribution, and every distribution has unique mgf if it exists. This is if and only if result. So if mgf is given, they will decide unique distribution. If you have already known the distribution, it will decide unique mgf if it exists. So now we have the distribution of x and y. Now the support, we know the x can take values 0, 1, 2. Yes, yes. So I use this theorem.
Is it 2 comma 1 by 4?
No, see carefully. Okay, let me check. So I use this theorem. Theorem number 2. Let's say theorem number 1, theorem number 2. So you read the theorem number
Yeah,
2.
for
Got it? Okay.
for x1 n comma p, it's 2 comma 1 by 4, right?
Oh, let me check 1 minute. So take 1 minute. Yes, yes, yes. I write it wrong. Yeah, that's my mistake. Correct. Yeah. So x is binomial 2 comma 1 by 4. Yeah. Y is binomial 3 comma 1 by 6. Correct. So x can take value 0, 1, 2 since it is binomial 2 comma 1 by 4, and y can take value 0, 1, 2, 3, right? So you know the value of x and y can attain. Now come to the question. So question is, what is the probability of x plus 2y will be more than 1? So let's take complement. So now if I want to find probability x plus 2y strictly more than 1, so 1 minus probability. Okay, so if you do the complement, so what will happen?
1 x plus 2y less than is
Less than or equal
less
to
than equal to.
1. Now you write all possible combinations. So 1 minus. So you see all possible combination it can be. So it is like you can see that 1 minus probability x plus 2y may be 0 or x plus 2y may be 1. There are only two possibilities because less than equal to 1. Now you write the possible values of pair xy, then we can find directly probabilities. So let's decide 1 minus. So x plus 2y will be 0. So there are only one possible case, x is 0 and y is 0. There is no other case. X plus 2y can be 0 only when x is 0 and y is 0 both. Minus. Now you have to decide x plus 2y is 1. So when x plus 2y can be 1, x can take value 0, 1, 2, y can take value 0, 1, 2, 3. So only possible here is, possibilities here is what? X is being 1 and y is being 0, right? Any other possibilities? X is 1, y is 0. If you take x 0 and y 0, so it will be 0. If you take y 1, then it will be 2. Yeah, right? So this is only possibility. Check it. Now let's find. Since we know that x and y are independent, so here joint MGF was the product of marginal MGF. So we know x and y. This is also if and only if result. X and y are independent. And when x and y are independent, then joint thing can be written as product of marginal. So means a 1 minus, I can write it probability x0 and probability y0. And next thing I can add probability x is equal to 1 into probability y is equal to 0. And now since we know the distribution, so I can write the probability. So please write the probability and see whether are you getting answer or not. So let me write here. So if anyone has doubt here, you can ask whatever written there. Just calculate it using binomial PMF. So I will write there. So when x has binomial n comma p, So we know probability of x is equal to x is n choose x p raised to power x 1 minus p raised to power n minus x, right? So based on this result, if I write x is equal to 0, so it will be n choose 0 p raised to power 0 q is 1 minus p actually, so 1 minus p raised to power n, so it is directly 1 minus p raised to power n. If I write probability x is equal to 1, so it will be n choose 1 p raised to power 1 1 minus p raised to power n minus 1, that will be n choose 1 is n p 1 minus p raised to power n minus 1. So now I come to the question. So last step we solved till was it was 1 minus probability x is 0 into probability y is 0 minus probability x is 1 into probability y is 0. So this was the last step we solved it. Now just open it. So 1 minus, when you solve x power 0, so distribution of x was binomial 2 comma 1 by 4, so it will be 3 by 4 square. Y is 0, distribution of y was binomial 3 comma 1 by 6, so it will be 5 by 6 cube. Just I'm using this thing. So see here, x is equal to 0 will be this one and x is equal to 1 will be this. So you can calculate 1 minus x is equal to 1, so it is the x was binomial 2 comma 1 by 4, so it is 2 1 by 4 3 by 4 raised to power 1 because it is n is 2 into y is equal to 0, it is 5 by 6 raised to power 3. So can you calculate this? What is the answer? See, simplify it. So 1 minus 9 into 125, here 16 into 256, 9, sorry 216, I think 6 into 6 into 6 216, minus here it will be 5 by 125 into 6, so again 6 into 125, and here will be 4 4 16 into same thing 16 into 216. So just simplify it and you will get the answer. So 16 into 216, that you can take the LCM now. So just simplify it and tell me the final answer, any one of you. So I think this is a calculation. Huh? So if I first try to solve this, this will be 16 into 216. If I take minus common, it will be added. So 15 into 125, right? Now you just take LCM. Okay, so you just use the calculator by this point of time, or you solve yourself. This is not difficult. Just you have to multiply 16 into 216 minus 15 into 125 upon 16 into 216. It is 3456, I think. Okay, you calculated, fine. And so I think the answer one of you is giving is 1581 out upon this. So check, is this the option? So let me check. This is given option 1581 upon 3456. I think first option is correct. Yeah, so you calculated right. So anyone has doubt, you can ask in this question. So if you want to ask something. So the theory I used is here. So theory I used is here. So I started with this is a definition of joint MGF that I didn't use actually. So this was the theorem that says random variable are independent if and only joint MGF is product of marginals, and here if X is binomial NP, then MGF will be this one, and where Q is actually 1 minus P. So here Q notation is 1 minus P. If X is binomial, the support is this. Support means range of the random variable, and this is the probability mass function. And based on this, just I calculated X is equal to 0 and X is equal to 1 because we need this. And then this was the further calculation, and then we got 1581 upon 3452. That is the answer. So okay, I think we should go to the next question. So one question I solved was based on Bayes theorem, and this is from December 2023 paper. You can check original paper. And the fourth one was based on the joint MGF and the binomial distribution. Now come to the next. So this is the testing problem. Yeah, you want to ask something, anyone? You can write in chat or you can unmute. So I will skip this higher part. So I try to just use the basic probability things that you might have studied during BSc mathematics, MSc mathematics. Yeah. Yeah, this is for net, CSIR-NET. Yeah. So it is for CSIR-NET. So please explain the
Hello, sir.
distribution. Yes, yes. Ask.
Sir, I have one doubt. You told that NGS uniquely determines the distribution,
Yeah,
right?
yeah. Actually, yeah.
Is it true in the case of continuous distribution also, or we can say it in the case of discrete distribution?
Yes, yes. For every. So the theorem is uh, every distribution. So distribution, I mean every distribution, whether it is for the discrete random variable or continuous or mixed, any. So every distribution has unique MGF if it exists. So it may not exist in some cases. For example, the Cauchy distribution. So if it exists, then it will be unique. Further, converse is also true. Further, every MGF determine unique distribution. Okay. So for the reference, you can see this theorem is clearly written in the book. So you can refer to the book VK Rohatgi and AKMD Saleh. So title of the book is Introduction to Probability in Statistics. They have written very good way. The book is very good. So Introduction to Probability in Statistics. So in this book, you can find this theorem is clearly written in the MGF topic. I think it is in chapter 2 or 3. Chapter 2, I think. Okay, so whether it is discrete or continuous or mixed, so it will have unique distribution. I think Amin was asking, okay, how did I calculate distribution of x and y? Yeah, so this is the theorem I used. This is the theorem. See, so the theorem behind the distribution is this: X has distribution binomial NP if and only if the MGF will be of the form Q plus P e raised to power t whole power n. So since our MGF was this form, so we decided that it is the binomial. So if X has distribution binomial with parameter n comma p, if and only if, so it is a both way correct, if and only if MGF will be of this form. So since we have seen that MGF was, so see how did I calculate. So it was like I think 5 by I think you see just question 3 by 4 plus 1 by 4 e ki power t whole power 2. So just compare this and this. So what will you decide? If you compare, you will find it is binomial. In place of n you have 2 and in place of p you have 1 by 4. So in this way I decided the distribution. Got it? Yeah, fine. Okay. So I solved two questions. Now next is the third question from random variable. Again, I want to show those who are from mathematics background. Even in BSc mathematics, you might have studied one course, probability statistics. Even in MSc mathematics, you might have studied one course, probability in statistics, and that covers basic probability part and random variable part. So I'm trying to solve only those questions which are from basic probability or the random variable. So last question was from random variable. Seventh question is also from random variable. So let us try this. So let's try this seventh question. So seventh question is saying, so it is again from December 2023 paper. So all of the question I solved was from December 2023 paper. So suppose x is Poisson 3 by 4. So random variable x has distribution Poisson 3 by 4. Then which of the following statement is true? So now you have to decide whether probability x more than 9 will be more than equal to 11 by 12, x less than 9 will be more than 11 12, or probability x minus, sorry, expectation x minus 3 by 4 raised to power square will be more than equal to 11 by 12, or 11 by 9 x is Poisson 11 by 12. So this you have to solve. So okay, let's try. So now the first three option involves inequalities. Okay. Okay, so first let me explain the theory behind this question. Okay, so the theory behind this question is, so I think you might be knowing Markov inequality. Yeah, anyone know this? Markov inequality. So what is the statement of Markov inequality? So it is saying if x is non-negative random variable, then probability x more than equal to some constant k will be less than equal to expectation of x upon k, where k can be any positive real number. Okay, so this is the theorem I will be using for one of the options. So if x is a non-negative random variable and the probability of x more than equal to k is less than equal to ex upon k. Okay, so in the question, what we have given, x has Poisson 3 by 4 distribution. So x has distribution Poisson lambda. So anyone tell me what is the expectation of x here?
3 by lambda.
Yeah, it is just lambda, so it is 3 by 4, correct. So okay, so let me write it in the other way. So it is the more than equal to. If I take the complement, so 1 minus probability, so that is 1 minus probability x less than k, that will be less than equal to ex upon k again. So just shift the 1 into right side. So probability x less than k, if you simplify, so probability x less than k, you shift right side, will be more than equal to 1 minus ex upon, you just some manipulation. So after some manipulation you will find this. So probability of x less than k is more than equal to 1 minus ex upon k. Okay, so this is the one of the form. The first equation is this one and the second equation is this one, both are equivalent. Okay, so both are equivalent. So the first one and the second one. So I think here I might be using, okay, so let's write here. So probability, it is saying first option say x more than 9. So x more than 9, so it will be less than equal to first of all. So first option may not be correct, so it is wrong. Asa, is true actually, the single correct option is there. So this question will have only one correct option. So if you find that one correct option, rest option don't need to check, because this is from MCQ part and part B of the paper. So just one option will be correct. So let's decide this one option. Okay, so if x is more than 9, it will be less than equal to something, and there is no such option, so that will be wrong actually. Okay, so what I'm trying to say, so probability x more than 9 will be less than equal to some, this will be ex upon some 9 actually, but there is no such option, na? But if I write the other way, x less than 9, so it is more than equal to 1 minus ex upon 9. So I'm using the Markov inequality I have written here, check. So the first form was this and the second form. So I'm writing second form now. X less than k is more than equal to 1 minus ex upon k. So 1 minus ex upon k. Now put it here. So 1 minus, what is the expectation? 3 by 4 upon 9. You just simplify it. I think it will be, check it. What will be this? 11 by 12. Yeah. So we got that probability x less than 9 is more than equal to. The second option is correct. So it is MCQ, so I don't need to waste time on other questions because I know just one option will be correct and we found that correct option. That's all. If it is MSQ, multiple select, more than one option may be correct from part C, then we have to check on each option whether it is true or false, true or false. But since second option is true, we got it. So you don't need to do other part because it is MCQ part. Okay. So anyone has doubt in this question, you check. Just Markov inequality I used in this question. Got it everyone? So no doubt in this question. Okay. So second option is the correct option. Yeah. Okay. So this was the theory for this question. Only this was the required theory. Let's move to the next question. So the next question is, so again, 8th form regression analysis. I will skip this. It is regression. Jointly minimum sufficient is estimation. So this we may skip. So I will try to use the thing where mathematics people are also comfortable. UMBUE that can be calculated easily. We can see. So let's try to solve 11th question. So I'm trying to solve basic probability and random variable part
Sir?
only. Yes.
Sir, there are different inequalities, no, sir, like Chevikse inequality. How can we find from the question we have to use this inequality?
Yes.
Any idea on that?
Yes, yes. So you know the form of every inequality. So if it is Chebyshev's, then it should be of the form. So you know the form of Chebyshev's inequality. So and options itself gives a hint that what should be used. So if it is this or if it is this, so I will using Markov inequality. How will I get the idea? I have to use Chebyshev's inequality. So the form of Chebyshev's inequality is, so it is like probability mod x minus mu more than equal to k is less than equal to variance of x upon k square. So if it is of this form, then we'll get the idea we have to use Chebyshev's inequality. So the standard form, you know, so if options is in that that form, then we'll decide. If it is something like this, then only we can, if you open it, it will be x more than something less than something. So that will be the form. So it is not the form there. So the one answer is, possible answer is practice. So if you practice, then we'll get to know that. When do we use Markov inequality? Yeah. So there are only few inequalities there, like Markov inequality, Chebyshev's inequality, Jensen's inequality. So you have to decide which will be used. Jensen's inequality. So it is saying if some function g is convex function on support of x, then x is a random variable, then expectation of gx will be more than equal to g of expectation of x. So by practice you will understand. So how do I get the idea that I will use Markov inequality? So it will hit and trial. It is not like sometimes I messed up also. So maybe it is not the that I'm thinking. But since I started solving and I got the answer, so that is the point. And the question it is framed was based on Markov only. That's why I got it the correct answer. So the thing is form. So here it is giving the bound of probability x more than equal to k and the probability x less than k. So Markov will give bound on these things in terms of expectations. And Chebyshev's inequality gives bound on this probability mod x minus mu. Mu is the mean actually. So here mu is the expectation of x. So then you will see the what is the form. So this, if this is the form, then I will use Chebyshev's inequality. Here it is expectation of gx. So if it is expectation of some function of x, then I will use. So the simple thing is you need to know every inequality and you know the standard form. So directly option was based on this form. That's where I decided that I will use Markov inequality because it was probability x less than k or more than k. That's why. Okay, and that was the correct approach. I got the right approach here. So since this is giving the hint that I have to use the Markov inequality, because if you find the probability of each point, then it will take a lot of time. So you cannot find the probability easily. So that's what. Okay. Okay. Come to the 11th question. 11th question is also from random variable topic. So it is saying that x be a discrete random variable with support. So support is the range of random variable. S is set containing -1, 0 or 1. Okay. Now, probability of x at 0 is 1 by 3. Which of the following statement is true? Again, this is an easy question. So, R true. So, now it is MCQ. R true they have written. So, maybe one option correct, two option correct, three option correct, all four are correct. Maybe. So, you have to check on each option, unlike the last question. Last question was single correct. So you have to choose just one option. Here it may be more than one option correct. So we have to check on each options. So let's try. Okay. Okay. So you can also try, So what is the expectation of x? So let me write the theory behind this. So if you write expectation of x, since here x is a discrete random variable, so x is a discrete random variable, then expectation of x, you all know it is x into probability at x, whatever the possible value of x is. So whatever the possible value of x is, this is simple. Ex, if I find ex square, so it is the summation x square probability at x and x from minus infinity to plus infinity. And using these two results, we know variance of x can be written as e of x square minus ex whole square. So that is the variance. So if you calculate this and this, then you can find the variance. So this is the only theory required to solve this question. Okay, see. So ex square, and anything like e of gx. So e of any function gx, it will be summation gx into probability at x, x from minus infinity to plus infinity. G is any function. So use this concept to find the question. Okay, so let's solve this question. So tell me what will be the ex. So if I write the ex here, so it is summation x into probability at x, and x can take value here minus 1 to 1. Just put the value. It is a PMF. So probability x at minus 1 plus probability x at 0 plus probability x at 1. So it will contribute equal to 1 by the definition of probability mass function. So probability at minus 1 plus probability at 0 plus probability at 1, this will be 1. And at 0 we have already given 1 by 3. So using this equation I can write, so solve this first. So if you put it, so it will be 1 into, so it will be 1 into probability at 1 plus 0 into something 0, then minus 1 into, then minus 1 into probability at minus 1. I think that's right below. Check it what I'm saying. So it will be, so probability x at 1 minus probability x at minus 1, this will be ex. So x be a discrete random variable which support this, and the probability at 0 is 1 by 3. Then how will you decide? So expectation will be less than or equal to 2 by 3. I think it is no. If I take the one case, where suppose both are equal, then it will be 0. Okay, maybe. So we have to use, I think, some kind of inequality or something there. So let's try first, second, third, or fourth option. Then I will come to the first one. So what is the ex square? Ex square, if you find, that will be just simply 1 square. So probability at 1, then probability at 0, 0 into probability at 0, 0, and then probability at minus 1, right? And this sum you know already, because x is equal to 0 is 1 by 3. So then probability at, okay, you got it, fine. So here you got it, actually this is the 2 by 3, right? And probability of mod x in the similar way, you will get probability at minus 1. So that will be also 2 by 3. And then variance x. So variance x is actually, so variance x will be what? It is the ex square minus ex whole square. Now, so okay. Variance x is ex whole square minus ex. Okay. and ex square is actually 2 by 3.
Sir,
Yeah,
variance of x will be expectation of x square minus expectation of x the whole square, right?
yes, that is the formula.
Reading by
Yeah, the same thing. Variance of x, if you write, this is the formula. What you are saying is also correct. Whole square. This is the formula, you know. And if I further simplify it using a plus b whole square, then it will reduce to ex square minus ex whole square. So the same formula will reduce to this form. Okay. So the same thing, you can, anything you can use. You can use this or you can use this. Okay. So either you can use this or this.
but you
Now,
didn't write the square.
okay. So I missed this. Yeah, actually. Yeah, okay. So ex square minus ex whole square. So now ex square minus ex whole square, and that quantity will be always less than ex square, right? And ex square is actually 2 by 3. So now check this, because it is a mean square, na? This is a positive number. So this quantity will always be less than this one, and this at least equal if it is 0. And that quantity is 2 by 3. So now D is wrong, na? Yeah, fourth is wrong actually. What about the first one? Okay, so second is correct, third is correct. Yes, yes, thank you. Huh. So I missed here, huh? That now it is correct. So here I think I also here also missed, or what? Here ex whole square. There is a square. Okay. Huh. Yeah, yeah. Okay, correct. So now it is fine. 2, 3 is correct. What about 1? How will you decide as probability of 1? So we can do one thing. The probability of -1 plus probability at 1, both are 2 by 3. So I can replace this as, and this quantity can be replaced. So it will be like probability at 1. And so what I'm saying from here, see. So probability at -1 plus probability at 1, both will, sum will be 1 minus 1 by 3, that is 2 by 3. And this is 2 by 3. And what we got ex, it is actually summation. So finally I'm writing answer. So we got that probability at 1 minus probability at -1. So using this equation you can further simplify. So probability x is 1 minus, this can be written as 2 by 3 minus probability at 1. So it will be actually 2 times probability at 1 minus 2 by 3. Is it? Check. Now what can you say about this? So probability x is equal to 1, this. So if it is, suppose it is uniform distribution. So if I, in case, if I suppose it is uniform, x be a discrete random variable which support this. And the probability x is equal to 0 is 1 by 3. So how can we find the bound of x? So ex whole square will be more than ex square. Are true. So how can you check option 1? Anyone has idea? So we have got here 2 time probability at 1 minus 2 by 3. Is it? Or I can do one thing. If I have used here, instead of putting -1, if I put 1, so ex will reduce to what? If I write here, okay, so better it is, see again I'm solving this. So ex was probability x is equal to 1 minus probability x is equal to -1. So probability x is equal to 1 can be written as 2 by 3 minus probability at -1. Is it? And now probability at -1. So that quantity is actually 2 by 3 minus 2 time probability at -1. Now this quantity is surely less than 2 by 3. That's all. Yeah, done. So it is correct. So Ex, this quantity will be less than equal because probability is always non-negative. So this quantity will be less than equal to 2 by 3. The first option is okay. So first option is also okay. So anyone has doubt now? For 1, 2, 3 are correct. So you can ask if you have any question in this, any doubt. I think everyone got it. Okay. Okay, 1 minute. Let me on the fan. Okay, so let's go to the further next question. So that we can solve 12, but it will need a random sample without, it is a random sampling. So let's come to 13th question. It's also from a random variable topic, 13th question. So it is easy question, direct based on theorems. So u is a uniform 0, 1 random variable and x is a tan of pi of u minus half. Then which of the following is correct? So let me tell you few theorems regarding this question. So if x is uniform 0, 1 or it is yes uniform 0, 1, you know what, so what is it saying? I think u is there or x is there, u is there, no, u is there. Okay, x is tan pi u minus half. Let me solve here. So u is uniform 0, 1. So u minus half will have what distribution? Anyone has idea? What is distribution of u minus half? This is direct theorem actually. So u is between 0 and 1. U minus half between minus half and plus half. Yes. So it will be uniform minus half to plus half. And then if you take pi time u minus 1 by 2. So if you multiply pi here, so pi time u minus half will be less than pi by 2 more than minus pi by 2. So this will have distribution uniform minus pi by 2 to plus pi by 2. Till now is fine. So what theorem I'm using here? So this is the result. So instead of, so if u has uniform distribution interval AB, then k time u will have distribution uniform k time A comma k time B, where k is some positive number. In fact, if I write u minus some k, this will have distribution uniform A minus k to B minus k. This is a theorem where k can be any real number here. Okay. So I'm writing then. The first point is this. Second point is this. So this is being used in the last theorem. One more theorem I will write. So if u has uniform minus pi by 2 distribution, then tan u, so tan is a trigonometric function, tangent. So tan u will have, anyone has idea what will be the distribution of tan u? So this will be a standard Cauchy distribution. So this will be a standard Cauchy. What if k is negative? So then opposite will be happen, no problem. So if it is k is negative, then so when k is negative, it will be kb to ka. When k is negative, the logic behind this is, so when u is between a to b, if k is positive, ku will be ka to kb. When k is positive, and when u is between a and b, when k is negative, so ku will be, so that is the logic. Okay, so that's what, when k is negative, so that's what, yeah. So if it is k is negative, then it will be this. Okay, so now done. So this theorem is being used. This two theorem I will be using in this question. See carefully. If it is uniform minus pi by 2 pi by 2, then 10 uses. Now see this. So let's come here. So pi time u minus half have distribution uniform minus pi by 2 pi by 2. So u was uniform 0 1, u minus half is this one. Then pi I multiplied. Now tan of pi u minus half, this will have distribution standard Cauchy distribution. Standard Cauchy. So sometimes book write Cauchy 1 0 or 0 1 type this. So standard Cauchy. So this is the x. So now x has distribution standard Cauchy. Again, this is a MCQ, MSQ, more than one correct option. So we have to think over each option. So now tell me. So standard Cauchy, so what is PDF of x? So PDF of x will be 1 upon pi 1 plus x square when x is any real number. Yeah, so got it? Fine. So this is the standard Cauchy distribution. Now you can easily decide. So I got the distribution of x now. So x distribution of x is a standard Cauchy distribution, and using a standard Cauchy distribution, she said it right. So let me solve further here. So in this question we are solving. So we got PDF of x is actually 1 upon pi time 1 plus x square, and x is real number. So this is the PDF of probability density function of a standard Cauchy distribution. And now, so if you find probability x less than equal to 0, you just integrate minus infinity to 0 1 upon pi 1 plus x square dx. Just it is the tan, you just calculate it. It is then 1 by pi, that will be tan inverse x. Tan inverse x, and limit is minus infinity to 0. You solve it. So it will give you answer 1 by 2. Correct? Check. So option D is correct. So option D is okay. I was discussing MGF, है ना? So I was discussing MGF. If you write the moment generating function, so we know what in case of standard Cauchy, MGF is e की power tx. This does not exist. MGF does not exist actually. So, MGF does not exist in the neighborhood of t, where t belongs to some interval minus epsilon to plus epsilon. So this does not exist. So if you put t is equal to 1, so if you put t is equal to 1, it will be x e की power x. Yeah, I think it will not exist. It will not exist. So using, since MGF does not exist, so I think this will also does not exist. And what if x belongs to 1 to 5? So the second option is saying, probability x belongs to 1 to 5. So it is saying actually x is equal to 1, x is equal to 2, and x is equal to 5, like this. So it will be 0 plus 0 plus 0 is 0. Why? So again I'm saying here one theorem. X is a continuous random variable if and only if probability of x is equal to x is 0 for all x belongs to R. So this theorem I'm using here to say probability is 0. Anyone has doubt? So this is 0 actually, B part, and it was saying it is 1 by 2. That's, it is wrong. So this option is wrong. E of x raised to power 4. Now I have to find e of x raised to power 4. Actually, in what happens? In case of this distribution, MGF does not exist, and e of x की power n also does not exist. This does not exist for all n belongs to natural number. Actually, what I'm using is properties of a standard Cauchy distribution. So in case of a standard Cauchy distribution, moment does not exist, and also expectation. If you write the expansion of e raised to power x, it will also involve some ex square, and e x raised to power n does not exist. So what I'm saying, so again the next theorem what I'm using is, if x is a standard Cauchy distribution, then e of x raised to power n does not exist. Does not, well, mean its moment does not exist actually for all n belongs to natural number, does not exist. Okay, so that's when option A is also wrong. Yeah, now ask your doubts if you have any. So no doubt so far. Yeah, so yeah, Elijah tell correct answer in the chat. Yeah, it is fine. Okay, next come to the next question. Come here now. 14th is also from random variable. Okay, so let's try this 14th question. So x is a continuous random variable with PDF this. So again, this is a Cauchy distribution, but it is not a standard Cauchy. Okay, so if I write here, the x is actually Cauchy in place of, it is -1, 1, like 0, 1 or 1 minus 1 you can write. So parameter you may choose as per your convenience, 1, -1 also you can write. It depends on you write theta or mu first. So it is a Cauchy distribution again, what I'm saying. And the next is y is actually signum function of x. So you know signum function. So this is the y is the signum function of x. So they are asking then which of the following are true. Again, more than one correct option. So which are true actually? So can you calculate now? So it is a Cauchy distribution. Like I said, e of x raised to power n will not exist, but it is y actually saying. You know, this will not exist. This will not exist for n belongs to natural number. Okay. In fact, if n is any real number more than 1, it will not exist. So, okay, so now try this. So we have to work on this y. So let me solve here. Okay, y, if I write further, you can note that if x is positive, y will be 1. If x is negative, y is -1. If x is 0, y is 0. Do you agree? See this carefully. So y is 1 when x, because when x is positive, mod x is x. When x is negative, mod x is -x. So x upon x is 1, x upon -x is -1, and 0 already given. So now let's work on this first option and fourth option first. So it is saying ey is 0 and ey square is 1. So let's work on this. So in the 14th question, a PDF of x is given as 1 upon pi 1 plus x plus 1 whole square. X is a real number. Y is given as 1 when x is positive, -1 when x is negative. So let's calculate ey. So it is like I said you, it is a signum function of x. Okay, so e of sgn of x, signum function of x. So it will be integration -infinity to +infinity sgn of x into pdf of x dx. By definition, simply by definition it will be this. Now you have to break into two parts. So you have to break into two parts. So -infinity to +infinity. So first you take -infinity to 0 and then you take 0 to infinity. So when you take x from -infinity to 0 means x is negative, so it will be -1. So -1 time PDF of x dx. And when you take 1 into PDF of x dx, because when x is positive it is 1. So now the challenge, you have to solve this integration. So it will be -infinity to 0, you can take minus outside. This is the PDF, 1 upon pi 1 plus x plus 1 whole square dx, and plus again same thing 1 upon pi 1 plus x plus 1 whole square dx, 0 to infinity. Now can you integrate this? Yes, it is not difficult actually. So 1 by pi you take out, so the tan inverse x plus 1, and the limit is minus infinity to 0, and here is 1 by pi tan inverse x plus 1, and the integration is 0 to infinity. Okay, so if you solve this, this will be minus 1 by pi tan inverse, this will be tan inverse 1 minus tan inverse minus infinity, that is the minus pi by 2. So tan inverse minus infinity, that is the minus pi by 2 divided to pi by 2. Okay, plus you just check the calculation, you solve by yourself and then see I'm doing right. So tan inverse, this is pi by 2 minus 0. Now you simplify this. So if you simplify it now, 1 by pi, if I take common from whole, so it will be pi by 2 minus tan inverse 1 minus pi by 2. Okay, just I took 1 by pi common, so this cancelled. So answer I got is tan inverse 1 upon pi. This answer I got as a EY. So anyone has doubt, you ask, or you see, do you agree with these calculations? So means what I want to say, they said that EY will be 0, I say it no. Now come to EY square. So if I do EY square, so let's do this. This is easier to solve actually. So if I solve E of y square, so EY square is actually,
Sir,
yeah,
tan inverse 1 can be written as pi by 4, right?
pi by 4.
Tan inverse 1.
Yes, yes, you are right. So tan 1 is actually tan 45 degree 1. Yeah, you are right. So we can further write it. Tan inverse 1 is actually pi by 4. Pi will be cancelled, minus 1 by 4. Yeah. So this is minus 1 by 4 actually. Yes. But EY we got is minus 1 by 4. That is not 0. Yeah. So, fine. So correct. EY square if we solve, so it will be easier. You know what happens. So signum function was this. If I ask you what is the y square, so y square will be 1 if x is non-zero, and 0 when x is 0. Right? If you write the y square, if you square this function, if you square this function, so that will be directly, you know, 1 when this, so it is easy now. Just if you remove 0, nothing will affect, because at 0 probability is 0. So for the continuous random variable, if you remove 1 point, it will not affect. So SGNX whole square, so that will be the expectation minus infinity plus infinity SGN of x into, now PDF 1 by pi 1 plus x plus 1 whole square dx. So now you can break into two parts. If you remove the 0, it will not affect anything. So for non-zero function, it is 1 actually. So minus infinity to 0 and 0 to infinity. So what I'm saying, just 1 point will not affect. This will be 1 itself. So you can just write minus infinity to plus infinity except 0. So 0 can be ignored, and then it is 1 time pi into 1 plus x plus 1 whole square dx. Just I'm ignoring x is equal to 0. So here x is non-zero. Then I'm writing. And minus infinity to 0 and 0 to infinity. 0 is just ignored. So still you will get the answer 1 actually. So this is a PDF, and integration of PDF is 1. So at one point there is no mass. What I'm saying, at x is equal to 0, probability is 0. So it will not affect the continuous distribution. So now it is 1. Okay. So EY square is 1, that is fine. Any doubt here? So square was there, signum function square was there. So square is 1 actually, signum function square is 1 when x is non-zero. So minus infinity to plus infinity, if you remove 1 point from integration, it will not affect. So it is 1 actually. So that is okay. Now the option is 2 and 3. So x, y more than 0 and y less than 0. You can calculate. And y less than minus 1, y more than 1. Okay, so let's solve 2 and 3. So if I go in 2 and 3, so we have to find probability y more than 0, y less than 0, y less than minus 1, y more than 1. And we don't need to find actually, just we have to justify. So see what will happen. So here if I find probability x less than minus 1, so means we have to integrate, it is x less than minus 1 means minus infinity to minus 1 the probability 1 upon pi 1 plus x plus 1 whole square. Now can you integrate this? So if you integrate it, it will be actually 1 by 2. Now question is you check whether it is true or false. So 1 by pi outside, tan inverse x plus 1, and then tan inverse 0 minus tan inverse 5. It will be 1 by 2 actually, check it. So what is happening, after minus 1, the probability here is 1 by 2. This probability here is 1 by 2. So check carefully. We just have to compare. So you can see one thing. So probability, this is 1 by 2. If I write probability x more than minus 1, still it will give you 1 by 2. Okay, x less than minus 1, x more than total probability is 1. Now we had to compare here. We had to compare the option B was the first, compare option C. So y less than minus 1 and y more than 1. Okay, let's compare. So y less than minus 1. So y less than minus 1 and y more than 1, and they are saying this will less. So this we calculated half. Probability y more than 1 will be more than half. Do you agree? This probability will be more than half? Yes or no?
No, sir.
No. You know why? Because more than minus 1 is half actually. So more than 1 will be less than half for sure. So it will not be more than half. So probability y more than 1 cannot be more than half. So we don't need to calculate. Actually, we can decide from here. Because minus 1 to plus infinity, this probability is half. So how can be 1 to infinity become more than half? So this is false. So option C is false actually. Now come to option 2. Option 2 is saying y more than 0 and y less than 0. That you have to compare. So let's see again. So y more than 0 and y less than 0. So y more than 0 less than. So y more than 0. Probability y more than 0. Probability y less than 0. I think this is saying more than. So y more than 0 is less than, I think say. So y more than 0 is less than y less than 0. Yeah. Now see again. Again I'm making this. So after minus 1, this probability is 1 by 2. Before minus 1, the probability is 1 by 2. Let's come to 0 now. So 0 is where? Here is 0, right? So after this 0, this will be less than half. So this quantity is less than half. Okay. And less than 0. So less than 0 will be more than half. So is this option true or false? Check. Can you decide?
It is true.
It is true actually, yeah. So it is true because 0 to infinity, probability y from more than 0 is less than half, and probability y less than 0 is more than half. So y more than 0 is kind of 0.6 for example, and y less than 0 is kind of y less than 0 is kind of 0.6 and it is kind of 0.4. So okay, let me check. So option 2 I got it right. Acha, you are thinking 3 is correct. Okay, let me check again. So y more than 1. So
No,
y,
sir.
yeah,
Yeah, I said it by mistake.
it is false now, correct? Agree? Yes.
Yes, yes.
Yes.
Yeah, yeah.
Fine. So now the in this option we got is 2 and 4 are correct. Okay. So it was MSQ, it is 4.75 marks question. So MSQ are, you already know, in CSIR-NET it is 4.75 marks question. MCQ is I think 3 marks question. So okay, this was 14th question. And again this is the, I think, multivariate analysis. So I'm trying to solve just probability and random variable part, basic random variable part. X be a discrete, yeah, this can be solved. This is the just binomial distribution question, question number 21. So the 21 is saying what? It is saying X be a discrete random variable with support 0 to 25, okay, with this PMF. So you can directly understand that it is binomial 25 comma 1 by 2. By this PMF you can directly decide X has distribution binomial 25 comma 1 by 2. And now which of the which of the following statements are true? So the distribution of X minus 12.5 and 12.5 minus X are identical. So it is again MSQ are true they are asking. So MSQ. So you know expectation of X will be n into P, that is 25 by 2, which is 12.5. And there is a theorem. So if a random variable is symmetric about any point, so it will have, so option A is true, there is just a theorem. So theorem is uh, so the theorem is a random variable X is symmetric about mu. Mu is the Ex. So if and only if X minus mu and mu minus X has, yeah, have same distribution, yeah, are identically distributed, you can write they are identically distributed. So they are identically distributed, okay. So X is symmetric about mu if and only if they are distributed. So you know binomial what happens, 0 25, the PMF at 0 will be same as PMF at 25 because it is binomial 25 comma half. So if you check, probability at 0 and probability at 25 will be equal. So like on 1 and on 24 it will be equal, on 2 and 23 will be equal, so and so on 12 and 13 it will be equal, okay. So here is 12.5. So it is symmetric about 12 point because at 13 and at 12 the PMF at 12 and at 13 will be equal, and so on it will keep on. So it is symmetric about this, it will work. So first option is okay. Second option, probability X less than equal to 4. So like I said, so the second option is saying, so I'm rewriting second option. So X at 0 1 2 3 4, and the equal to they are saying X at 22 23 24 25. So there are 4 points and there are 5 points. So do you think they will be equal? Yes or no? So like I said, probability at 0 and probability at 25 they are same. Probability at 1 and probability at 24 they are same. Probability at 2 at 23 they are same. Probability at 3 and probability at 22 are same. Probability at 4 and probability at 21 are same. But 4 is extra here, na? Got getting? So yeah, this 4 is, there are 5 points here, there are 4 points, they cannot be equal. So at 0 and 25 they have same mass, 1 and 24 has same mass, 2 and 23 has same mass, 3 and 22 has same mass, but 4 is extra, that's why this option is wrong. So it is symmetric about 12.5. So if you take, so 1 point is extra 12 4, that's why it is wrong. Now the coefficient of variation of X is 20. So what is formula of coefficient of variation of X? Do you have anyone an idea?
Yeah, it is standard deviation by mu into 100.
Yes. And you are saying in percentage, so into 100. If they are asking in percentage. So just we know the formula of binomial. So like I said, mean is this. If you write variance of X, so it is 25 into 1 by 2 into 1 by 2. So it will be 6.25. So this is a sigma square. So sigma will be root under 6.25. Okay. So the answer of the third question would be 6.25 into 100 upon mu. Mu is already 12.5. So 12.5. Do you think there will be 20? Check. I don't think so. So root under 6.25 upon 12.5 into 100 will be 20. I don't think. You check through calculators, you can check. Okay. So root under is root now. So I can write 12.5 square. It will cancel and then 2 time. I don't think. You just verify it. So it will not be. Okay. Now come to this point. Fourth option. So fourth option is probability x less than equal to 4.9. So again I will write less than equal to 4.9. The fourth option writing in the bottom. At bottom I am writing. So less than 4.9 means x is 0, 1, 2, 3, 4. Okay. And they are writing probability more than equal to 20.1. So it is 21, 22, 23, 24, 25. Now do you think they will be equal? Yes or no? Fourth option. So 0, 1, 2, 3, 4 and 21, 20, 21. There are 5 points here, 5 points here. So they have 5 points both sides. So at 0 and at 25 mass are equal. At 1, at 24 mass are equal. At 2 and at 23 mass are equal. So they are equal. Okay. So yes. So here option 1 and 4 are correct.
The third option is correct, right?
Third option.
Yeah. Root 6.25 by 12.5 will be 0.2.
Okay, that's what I'm asking actually. I don't know. That's why I was asking whether it is correct or not. So I didn't do calculus. I thought I guessed it is not 20, but it is. Check. Okay, let me calculate. So we
Yeah.
got
The
that.
square root of 6.25 divided by.
Okay, let's calculate. So I didn't calculate now. That's why I thought it is not. Okay, check. So that may mistake you can do. You just verify. So 6.25 root will be what?
2.5.
2.5. Okay. Okay. Then it might be correct. I think I have guessed wrong. So यहाँ से calculation करेंगे कितना आएगा? So now it is okay. So it is correct then. 225 upon 125 into 100. 20. Oh, it is correct then. Yeah. So I was thinking it will not come, but it is 20 actually. Yeah. So it is correct. Yeah. So I was
I
thinking
think
wrong.
rather than writing the decimal form, yeah.
Yes, we can have directly do. Yeah.
If you
So
write,
it will be better.
yeah,
25 by
if
4.
we can directly.
That's why I did more calculations. It was 25 by 4 only, and that will be easier to simplify. It was 25 by 2, that will be easy to solve. Yeah, actually. Correct. Yeah, thank you. So, third is also correct. Okay. So, I was thinking it might not come 20, but it is 20 actually. Okay. Now, it will be easier to like write 25 by 4, then root will be just 5 by 2, and here is 25 by 2, and then into 100. So, 2 cancel, 5, 20. Yeah, 20 it is. Yeah, it is correct. Okay, so now the correct options are 1, 3, 4. 1, 3, 4 are the correct options. Again, we can solve this question actually. 21. It is also from random variable. This was 21. They again re-answer. Oh, 21, 22, 23 should be there. So this is the 23 actually. Yeah. So this 23 number question you can check. So again, it is from random variable. Xi with the absolutely continuous random variable having PDF this. So if you check here, the xi have exponential distribution with parameter I. For all I is 1, I can be 1 or 2. There are just two random variables. So means x1 is exponential with rate 1, x2 is exponential with rate 2. So x1 is exponential with rate 1, x2 is exponential with rate 2. And now, so they are from reliability, but it is easy question. Okay. Consider a series system comprising of independent component having random life type described by the random variable x1 and x2. It is a series system. So what happens in the series system? So there is a machine. This is x1. This is x2. So this machine will work if and only if both component work. If either of the component fails, machine fails. So means if I write x is the lifetime of the system, so x will be what? Do you know? It is the minimum of x1 comma x2. This is a theorem again in the series system. So if any one is 0, x will be 0. 0 means machine is not working, 1 is machine is working. So out of x1, x2, if you put any one 0, the x will be 0. If any one fails, any one of the component x1, x2 fails, machine will fail. So x is minimum of x1, x2. And direct theorem is there. If x1 is exponential 1, x2 is exponential 2, then minimum of x1, x2 will have distribution. Can anyone suggest what is the theorem? So it will be exponential 1 plus 2 means
N
exponential
times
3.
lambda.
Yeah, lambda 1 plus lambda 2. So it is exponential 3. So x has distribution exponential 3. So the theorem is actually this one. If I write the theorem, so theorem is saying if xi's are independent, है ना? So xi are independently distributed as exponential lambda I, then minimum of x1, x2 up to xn. So for all I from 1 to n, this will be exponential 1 plus 2, acha, lambda 1 plus lambda 2. So this will be summation lambda I from 1 to n. That is the theorem actually. So if xi has exponential lambda I distribution, then minimum of xi will have exponential summation lambda I from 1 to n. So that I'm using here, and because of this x has distribution exponential 3. So the PDF of x will be actually rate is 3. So 3 e की power minus 3x. X is more than 0. So when will your classes for a statistics schedule for NET exam? So next batch will be coming after 1 July maybe. You can see on my YouTube channel, notification will be there. So so fx is 3 e raised to power minus 3x. Okay. And now you just solve. So here directly you can tell what is the expectation of x. It is exponential with rate 3. So the mean is what?
1 by 3.
1 by
1 by 3.
lambda.
So it is correct. Third option is okay. And the 6x. So if I write the PDF of 6x, so if y is 3x, sorry 6x. So we know the transformation formula. If I use the PDF of y, okay, so y is 6x. So if I write the PDF of y, so it will be PDF of x dx upon dy. So that will reduce to, or that there is a theorem if you want, or just I'm proving that. So it is the 3 e raised to power minus 3x, and dx upon dy will be, so dy upon dx is 6, so 1 by 6. So it will be 2 e raised to power minus, and you y is 6x, so x will be y by 6. So you replace x as y by 6. So it will reduce to, I think, y upon 2. Yeah. So actually here I proved that y is equal to 6x has PDF fy of y as, it will be 1 by 2, no? So 1 by 2 actually. So it will be 1 by 2 e raised to power minus y by 2. I think that is, see here I am writing. And it is a PDF of what? So 6x will have distribution exponential with mean 2. And coincidentally what happens? Exponential 1 by 2 is identically distributed with chi-square 2. It is also a theorem. So exponential 1 by 2 is identically distributed with, so exponential 1 by 2 is same as chi-square 2. They are identically distributed with chi-square 2 actually. So done. And what I said, so y is equal to 6x. The PDF of y is 1 by 2 e raised to power minus y by 2, y is positive. So this has distribution exponential 1 by 2, which is identically distributed with chi-square 2. So y has distribution chi-square 2 actually. So this is also true. Option 4th is also true. Now if anyone has a doubt, you can ask. Okay, so now 3, 4 is fine. Let's come to 2. Okay, 2 is the conditional probability. X more than 4 given x more than 2. So do you know exponential distribution follow memoryless property. So if you use memoryless property, then option 2 is directly true. Yes or no? So do you agree? So exponential distribution and geometric distribution satisfy memoryless property. And since x is more than 2 given and x more than 4, so memory is getting lost. So it is, so what is memoryless property? So the theorem is again, if x is continuous random variable, yeah, let x is continuous random variable. So x is exponential lambda if and only if and only if there is a single continuous distribution that satisfy memoryless property, and it is exponential only. So probability x more than t plus s given x more than s, this is equal to probability x more than t. That is the theorem. And the option 2 is direct this theorem. Just they have replaced s is equal to 2 and t is equal to 2. Only this one. So x is exponential lambda if and only if probability x more than t plus s given x more than s, this is probability x more than t. So this is a direct statement. B option is direct statement of memoryless property. So due to memoryless property, option B is correct. Now come to the option A, first one. So probability x more than 4 will be equal to, so let's write this. So x has distribution exponential 3. Okay, so 1 minute. So the question we got is x has distribution exponential 3. So PDF of x is 3 e raised to power minus 3x. So if you write probability x more than x, it will reduce to just this one. So probability x more than 4, it is e raised to power minus 12. Probability x more than 1, it is e raised to power minus 3. Probability x more than 2, it is e raised to power minus 6. So what they are saying in the option, more than 1, more than 2, more than 4. Okay, so if I multiply x more than 1, x more than 2, so multiply both, e raised to power minus 9, which is not equal to probability x more than 4. See, so you people agree this? Done. So now the option here is, first option is false. So now 2, 3, 4 are correct option. If anyone has doubt, please ask. Okay, so we solved generally questions from random variable and basic probability. So let's solve, see more questions.
Sir,
Yeah, ask.
we got the distribution of 6x as chi-square with the 2, right?
Yeah.
But in the option it was chi-square 3.
Oh, okay. Well, I didn't see actually. 1 minute, 1 minute. So again, it's my mistake. So yeah, I do some silly mistakes. You can sometimes. Okay, okay. This was my mistake. Yeah. So 6x actually, this is the wrong option again. So it is my mistake because I didn't see it is chi-square 3. So I thought it is chi-square 2, and that's the mistake. So only 2, 3 are correct actually. 6x has distribution chi-square 2 actually, not 3. So here it is chi-square 3. I didn't see this, and that's why it is wrong. So now it is fine. Yeah, it was my mistake. So so you have to see carefully. You know, sometimes we do mistake. I also do mistakes in exam. Then after exam, I realize, oh, it was chi-square 3. I didn't see. So you have to see carefully in exam actually. So if you do this mistake, then your marks will be cut. Like if I do the same mistake in exam, my marks will also be cut. So you have to solve carefully. So I didn't see carefully. I thought it's a chi-square 2 and then stick correct. So answer was actually the 6x was chi-square 2 actually. Yeah. है ना. So we find the distribution of 6x and it was chi-square 2. So it is chi-square 2 only. There's just a coincidence. Exponential with mean 2 is identically distributed with chi-square 2. Okay. Next. Yeah, try this question number 25. This is for June 2023 paper. This is very easy question, just based on the definition, right? And one more question was there. First solve this, then we'll go to next question. So it is very easy question, just based on the definition of probability density function. So you people tell me what is the answer. Fx is the PDF, it is given. It is saying fx is PDF on a real line, x belongs to R. So which of the following is not a valid PDF? So what is definition of PDF? So if I write the definition, so definition of PDF is probability density function definition is a function fx of x is PDF if and only if, first of all, fx should be more than equal to 0 for all x belongs to R, and the second is integration minus infinity to plus infinity, this quantity must be equal to 1. This is the definition of the PDF. So they must satisfy the two conditions. Okay. Yeah. So the PDF should be more than equal to 0 and integration over R should be 1. So you just have to check which of the following will not satisfy this condition. So we have given that fx of x more than equal to 0 and fx dx minus infinity plus infinity is 1. It is given to us. So now if you simplify it, okay, the second one will not give. So let's try the second one directly. F of 2x dx, I'm just integrating. So let's take t is equal to 2x. So dt is 2 dx. So dx is dt by 2. So it will be minus infinity to plus infinity ft, and fx will be dt by 2 and dx will be dt by 2. So 1 by 2 and now ft dt. So this is 1 actually. So answer is 1 by 2. But it should be 1. So yes, 2 is the correct. So question which is not a PDF. The question was which of the following is not a PDF. The second one is not a PDF. Why? Because the integration is not equal to 1. In the all other cases you will find integration will be 1 only. Just you do substitution. So in the first option you substitute t is x plus 1. In the third option here you substitute t is equal to 2x. Here substitute 2x is equal to minus 1. Here you substitute t is equal to x cube. Okay. So that's what. Done. So yeah, it is fine. Easy question. Next one. It is also from June 2023. This is again easy question. So last question was based on the definition of PDF. This is the based on the definition of CDF. So this is just based on the definition of CDF. So you tell me which of the following is a valid CDF. So again, here the approach is being used is, so this is the theorem, a function f from R to R is CDF of a random variable x if and only if the first condition is f of plus infinity should be 1, second condition is f at minus infinity should be 0, the third condition is f is right continuous, and the fourth condition is f is non-decreasing. Okay, so f is non-decreasing. This is the point. So plus infinity 1, minus infinity 0, right continuous, non right continuous means CDF at x plus at the right hand limit should be equal to CDF at x. Non-decreasing means if it is differentiable, then f dash x should be more than equal to 0. If it is not differentiable, then x1 less than x2 implies fx1 less than equal to fx2. So that you need to prove. Okay, so this you need to check the four conditions. So check in this question. Which of the four option is a valid CDF? So which of the following are the valid CDF? That you need to decide. So in the first option, if I ask you what is the probability f plus infinity, the f plus infinity means limit x tends to plus infinity fx. So now x is plus infinity here. So can you find the limit? This will be 1, I think. This is okay. So this will be 1, first one, and this will be 1 actually. Then minus infinity will be 0. It is also fine. Then the first option I'm checking first. So infinity at 1, minus infinity you put 0. Right continuous. So right continuous is more than equal to 0 is there. So that's what it is, right continuous. So it is a right continuous. It is right continuous. Now only thing you need to check is non-decreasing. So non-decreasing you need to check. So you do one thing. You just differentiate this. Okay. So if x is negative, so what will be its derivative? So if I write fx is 2 upon 1 plus x square when x is negative. Okay. So what is f dash x? Can you differentiate this? So if you differentiate, so it is a minus 2 upon 1 plus x square, and then derivative of 1 plus x square is 2x. So this will be positive because x is negative, this will be positive. This is fine. And in the other part, the CDF is actually 2 plus x square upon 3 plus x square when x is positive. So just I'm separately checking for negative positive. For the negative x, it is increasing function, non decreasing in fact. For the negative x, it is non decreasing, first option. For the positive, let me check. So you find f dash x. So what will be 3 plus x square whole square. Now if you differentiate it, check it what will come. So 2x into derivative of numerator into denominator, now 2x into this. So 6x plus 2x cube minus uh, 4x minus 4x cube. 4x cube? No, I think 2x cube. Yeah. So 2x cube तो कट जाएगा ना. So 6x minus 4x, 2x upon this. Again it will be positive. So it is in trouble. Now let's check on 0. So what is the left hand limit at 0? So see what I checked. The first option I'm checking, it when x is negative, it is the increasing function, non-decreasing function. If x is positive, it is non-decreasing function. Let's check in the neighborhood of 0. So what is the f of 0 minus? 0 minus means left hand limit of 0. So the value of CDF at left hand limit of 0. So it will be 1 by 2 because we will use this one, first one. And what is the value of 0 plus? 0 plus means CDF at right hand limit of 0. So it will be 2 by 3. And it is satisfying? Yes. So I think first one is okay. The other one is only will be wrong. Check it. Because it is right continuous, non-decreasing, and in 0 I also checked. So in the left hand limit of 0 it is 1 by 2. In the right hand limit it is right hand 0. The first one is okay, I think. See, you check people. The first option satisfy all the conditions. Value at plus infinity 1, value at minus infinity 0. And it is matlab it's the only correct option, single correct option question is there, I think. So non-decreasing, right continuous, value at okay, why is 2 is, if I justify why 2 is not the CDF. So if you find f at plus infinity, sorry, in the second option it will give you 1 by 2. That's why it is not a CDF. In the second option, if you find CDF at plus infinity, it will give you 1 by 2. It should be 1 actually. Yeah. In the third option, if you use f at plus infinity will not exist, I think. Check. So f at plus infinity, if you find in the third option, yeah, it will not exist. So this does not exist. Does not exist. That way it is not a CDF. F at plus infinity in the third option will not exist. Now come to the fourth option. So f at plus infinity will be 1 in the fourth option. There is no problem. F at minus infinity will be 0. This is also no problem. Now write continuous non-decreasing. So it will fail the non-decreasing condition. Why? In the fourth option, if you find CDF at 0 minus, so it will be 1 by 2. If you find CDF at 0 plus, it will be 1 by 4. Now they are not satisfying the non-decreasing condition. Why? Because 0 minus is less than 0 plus. 0 minus means left hand limit of 0. 0 plus means right hand limit of 0. Now I calculated the value of CDF at left hand limit, it is 1 by 2. CDF at right hand limit, it is 1 by 4. So now when value of x increases, the CDF decreases. So it means CDF is a decreasing function at 0. So the fourth option is decreasing function at x is equal to 0. And that's why it is not a CDF. So I proved also why 2, 3, 4 are not CDF. Anyone has a question, you ask. That is all. So you just need to check the 4 conditions mentioned here: plus infinity, minus infinity, right continuous, non-decreasing. Non-decreasing you can check in 2 way. Either you differentiate it and check at this separately for the each part. Then at the turning point you just check left hand limit and right hand limit. So what I said, if x1 less than x2, then f at x1 must be less than equal to f at x2. So 0 plus and 0 minus means less than this. But in the fourth option, what happened? It should be like this. This should be less than this, at least equal. But in the fourth option, this failed. And that's why it is the not severe. So I think that's all clear. Yeah. So again, we can stop. It is a 12 now. So we can do one more question. We can stop. So do you have idea of order statistics? Do you want me to solve this 28 question? So check. Let's solve 28th question. So this is the last question for today, I think. Yeah. So 28th question is x1, x2, x3, x4 be the independent identically distributed Bernoulli 1 by 3. So means here each xi can take value 0 or 1. You know, support of Bernoulli random variable is 0 or 1 only. So x1, x2, x3, x4 can take value either 0 or 1. Now x1, x2, x3, x4, they are the order statistics. Okay, so we know that, huh? So first order statistics is less than second order statistics, less than third order statistics, less than fourth order statistics. So they are, in this, in the discrete case, they might be equal. Okay. So the question is x1 and x4 are independent. No, actually two order statistics will never be independent in any case of distribution. So they will always depend. Why? The x1 is the minimum one. You know, x1 is the minimum one. So they will depend on each other. 1, 2, 3, 4. And the fourth is the maximum one. So two order statistics will never be independent, because if someone is maximum, they cannot be the minimum. So they will depend on each other always. So that's what this option is wrong. Now support of order statistics and support of the original distribution or the population will be same. Since each xi takes value 0 or 1, so the fourth order statistics will also take value 0 or 1. So means what I want to say, since the population is Bernoulli, so each order statistics may have different distributions, but it will have support 0, 1 only. So fourth one is wrong because it is saying degenerate. So degenerate means its support will have only one distribution or only one point. Support will have only one point. That is wrong. Now it comes to the second order, only the option 2 and 3. And this is a single correct option. So is correct. So only one option will be correct actually. So now we need to find the probability of second order statistics, and that is the, if we are able to find the distribution of second. Okay, what I wanted to say here, each order statistics will be Bernoulli equilibrium. I was said may not be, but it will be in this case. In this question, first order statistics, second order statistics, third order statistics, and fourth order statistics, all are actually these Bernoulli only. Okay, so you got it. Yeah, third is correct, that's fine. So we can stop here. Okay, I think so should I solve further, or you got it? Why? So you need to find the probability second order statistics is you may find one. So let's say second order statistics, you find this, and what is the probability of second order statistics being 0? If you can find this directly, you can see the distribution of this, and then you will decide this is correct. So she's saying right. Okay, so I think I should stop here. Time is also up. I'm getting call. So, sir, yeah.
Okay, thank you, Santosh, for this nice session with a good collection of problems. Now you may turn off the presentation. We can go for a feedback session. Okay, dear participants, feel free to share your feedback. And if you have any query regarding preparations for CSIR-NET of statistics portion, you can ask it now. This is actually the first time in MathAspirants platform we are providing a session exclusively on statistics.
Yes. People generally avoid this section actually, especially from mathematics background people. Yeah.
Okay. Yes, participants, feel free to share your feedback.
Hello, sir.
Yeah.
Yeah. My name is Elizabeth, and I am a postgraduate student in statistics actually. So, the class was really good because I was preparing for the CSIR presently and also for the ISS. And for the last 1 month, I was continuously engaged with the CSIR questions and also ISS questions. So, because of that, I could follow your questions and classes really well. And for me, I didn't solve the 2023 questions yet. So it was really helpful for me. And also, I have watched some YouTube videos also. So it is really helpful for students like us. So thank you, sir, for your valuable time and taking class time. Thank you.
Thank you, Elizabeth.
Yeah, thank you.
Yeah, many people are writing in chat box.
Yes,
Feel free to speak. Yeah.
Hello, sir.
Yes,
My name is Arya, and I'm studying MSc in IIT Tiruvandhuram. And first of all, thank you, sir, for this very good session. And it's really helpful for me to do the problems. And normally, I'm also preparing CSIR-NET, and I'm thinking that I will skip that statistics questions in exam. But now I have enough courage to do questions in statistics, and your explanation is so nice, sir, and thank you very much for this section.
okay, thank
yeah,
you,
thank you,
Arya.
thank you.
Hello, sir.
Yeah.
Sir, am I audible?
Yes, yes.
Sir, I am Adra Sandosh. First of all, let me thank Vinod, sir, for arranging such a wonderful section. Today's section was very helpful, sir. You have explained all questions in a simple way using the theorems. That helped me a lot. Thank you, sir, for today's section. Thank you. Thanks a lot.
Okay, thank you, Adra.
Thank you. So I would like, I would like to tell
other would like
others.
to say something, please make it now.
So I think I would like to tell the others actually, there are many questions, not all. So statistics is very broad area. If you see the syllabus, there are a lot of topics, linear models, and there are different topics, regression and all that. but those who are from mathematics background, you can touch questions from basic probability, like I solved Bayes theorem questions, basic random variable questions, PDF, CDF. If you just you might have studied probability statistics courses at BSc level, MSc level, that is enough to solve at least 10 to 20 questions from a statistics portion. At least not 20, at least 10 question or 5 10 question you can solve. Or if you can solve 5 question, means like if 2 3 questions from section C, then one question is from 4.75 marks. So it may increase your 20 30 marks easily from statistics portion. So don't focus on the advanced topics, at least you focus on basic probability portion, that is in 11 12th or BSc level or MSc level. Or random variable portion you can do Markov chain. Markov chain still may be difficult for mathematics background people, but random variable thing you can do. Random variable basic probability that I solved today. So you might have feel direct theorem is being used and it is easily solved. Yeah, thank you.
Santoshji, let me ask something for the participants. Could you explain what are the career opportunities after MSc Statistics rather than teaching and research?
Yes, sir. Actually, we statistics people have very good, very much opportunities. So one is in corporate sector, people are looking for statisticians or the data analyst or data scientist. So one with statistics knowledge as well as some computing knowledge, like some programming skills you have, whether R or Python or some other knowledges, then they can explore corporate. So there are a lot of opportunity in corporate sector. The people, like I was from IIT Bombay, I did MSc statistics from Bombay. So actually I was interested in teaching, that's why I didn't go to corporate. But almost all of my classmates, so like you say 90% of people joined, they are in Bangalore or Mumbai doing corporate jobs, and almost all year people get placed. So in a statistics, actually there very few people come into teaching field. Usually, especially people who study from IIT are going to only abroad. So the options are actually ISS. There is a one good job, like one of a student, Eliza, I think explained, Indian Statistical Service. They are exclusively for the statistics people. So UPSC conduct the exam and there you become a statistical officers, and then they have a lot of like UPSC conduct that exam, and it is a very good job, a grade A job. So ISS is the one of the opportunity. RBI offers exclusive job for the statistics people only. There is, I think, grade B, RBI grade B, DSIM, something the department is there. So they also offer for the statistics people only. So as ISS, RBI, then corporate world is the third option for the people, and then teaching is the obvious options they have. If they do PhD, then they can join university as assistant professor, and then they can help people.
Okay, let me ask one more thing. If someone doing MSc Statistics and would like to get a profession in data analysis, whether it is needed to do MSc Data Analysis after MSc Statistics, or even with MSc Statistics itself, may he or she get some profession related with data analysis?
Yes, sir. He can get. Even I know the people from mathematics background. They are like I also did MS in mathematics from IIT Delhi. So there was our senior Himani Upadhyay, and there are a lot of people who are now working in Bangalore as a data scientist or data analyst. So people from mathematics background are also doing this role, but they have to make some extra efforts. They have to learn coding, they have to learn statistics, they have to learn some computer science skill like algorithms and all that they have to work upon after MSc courses. So degree I think is not much important. The important is the skill. So if the skill are not taught in the courses, they have to learn separately, and then they can apply for the job. During job interview, they just see your skills, I think, not the degree. So MSc statistics degree is enough, sir, if a student have the skills to work.
Okay, could you suggest some online courses which is useful along with MSc Statistics for job seeking people?
Yes, sir. So actually, online there are many platforms. Here, Udemy or there are some online different Harvard University. These people they are providing now. NPTEL is also providing some skill based courses. So they might be useful NPTEL or Udemy or some. I think there are many different platforms that offer skill enhancement courses that can be done. Some are free and some are paid. So they can be done. I think I have to also have to some explore. I don't know much currently, but these are some platforms they provide skill based courses.
Okay, thank you, Santosh, for being with Math Aspirants, and please be there in future too to help our students. And wish you all success in your academic career. Thank you.
Yeah, thank you so
Thank
much,
you.
sir. Thank you for the opportunity. And today I solved only 2023 papers. So in future session we may see 2020 to 21. Today what I solved was from 23 paper only, 23 June and December papers actually.
We can also plan some sessions which are suitable for IIT JAM aspirants.
Yeah, sir, we can do, sir. Yeah.
Okay, thank you.
Yeah, thank you so
Thank you.
much. Thank you everyone for joining. Yeah.
Bye.
Bye, sir. Thanks.